All right, so last time we already talked about IVF, in vitro fertilization, and all the rest of these things. These three are kind of based on that technique, okay? They're taking IVF, in vitro fertilization, and adding on something else on top of it, okay? So, next one I want to look at is Intracytoplasmic Sperm Injection. Now, I'm just kind of going over the basics today, and then you'll have everything you need up here when you go to the Assisted Reproductive Technology clinics, ART clinics in Chicago and California. You'll have everything you need so you can figure out what they're doing and how they do it. All right, so Intracytoplasmic Sperm Injection. Based on the name, anybody have any idea what's it sound like? What's this? Sorry. Cole?
Sounds like injecting sperm straight into cytoplasm.
Excellent. Of the egg, right?
Naturally.
Yeah, that's what it is. Here's what it looks like under the microscope. Now, see, one of the advantages of getting older and teaching a long time, besides the fact that nice people at the store ask me if I need help carrying the water softener salt out, okay? Along with all that, one of the nice things is you get to know more people and you learn more stories. And you think I'm making these up, but I'm not, okay? I know a couple in Indianapolis. Actually, I think they live in Fishers. But, you know Fishers? Down by Indianapolis?
I think it's something else.
Oh, I know a couple who have 2 little kids, and both of them were conceived with this technique, ICSI, okay? Intracytoplasmic Sperm Injection. Cole is exactly right. That's what it is. It's taking a real fine-tipped, microscopic-tipped glass pipette and injecting a single sperm right into the egg, right through the cell membrane into the egg. In chemistry class, did you guys ever melt like thin glass tubes and stretch them out real thin? Did you ever do that?
No.
Oh man, okay. If you take a glass tube and hold it over a Bunsen burner, over the flame, eventually the glass will start to melt and it gets real soft, and then you can kind of pull on that tube and you can make the diameter of that glass that's over the flame get thinner and thinner and thinner, and eventually get really thin. And some of these technicians in these labs are really good. They can get these glass tubes so thin that the diameter is not much more than the size of a single sperm cell. Then they break the end off, and you got a sharp tip on it. You guys have never melted glass? Well, it may be a safety. It may be a safety thing. But anyway, that's what's happening here. Actual photograph taken through a microscope in an in vitro clinic actually this is in Indianapolis, as a matter of fact. So this couple that I was telling you about, they did this twice, and that's how they got both their kids. What's this?
Polar body.
Excellent. That's that polar body right there. So here, we're in an in vitro clinic. We're looking through the microscope. Why would anybody do this? Why do you think this couple that I know resorted to this technique? Gabby?
They didn't want to use the donor sperm, they still wanted to use the baby. Or maybe sperm just connect that to the
They wanted to use
the actual biological father.
the actual dad's sperm, for sure. Yes, that's part of it. And
Then maybe the sperm is having trouble getting past that barrier.
yeah, that would be another reason. In their particular case, Cole, what do you think?
He has a low sperm count.
Actually, no. He had a normal sperm count.
Like,
Well,
it
you're
couldn't-
partly right.
It couldn't line up with like the sperm, like couldn't line up with like the outer layer and like the sort of-
Oh, that's a good guess, but no, that wasn't their case. It's actually more, I don't know, you're gonna think, oh, that's pretty obvious when you hear it. Yeah.
Was it that the sperm couldn't produce was it the enzyme or whatever to break the outer?
And that's a good guess too. Well, you guys got it going on. Lauren?
I was going to say that perhaps your reproductive system was formed differently, so the egg was not able to get out the same way as.
Oh, that's a good guess. The egg could get out. Her fallopian tubes weren't blocked. Okay, the egg is able to move through the tubes like they're.
They just don't want to have sex yet? They don't want to, like, for marriage or something?
Pardon?
They just want it for, like, marriage or something, so they don't have, like, actual sex with that person.
Oh! Are you saying they weren't married
Yeah.
and they didn't want to have sexual intercourse, but they wanted to have a kid?
Yeah.
Actually, I've never heard of that. But that, I mean, that would be possible, but kids are expensive and that's interesting. I never thought of that. No, let me tell you what happened here. They're all good guesses.
I was gonna say the sperm doesn't have a tail.
Well, the sperms had tails. It's just that his sperm cells could not swim. That's all.
We never passed PD1.
Well, they couldn't swim. Now, he made normal sperm cells in every way except the tails. You know how sperm tails are supposed to go like this? His were like this. He made normal sperms, they just couldn't swim. He had a single gene mutation on his Y chromosome, that's all. A new mutation, such that his sperm cells could not swim.
Will that pass on to his kids like if he has a son?
Ah,
That's why the egg grows, right?
he's got a little boy.
Oh.
Uh-oh.
He's got a little boy. Who's the little boy get the Y chromosome from?
That big guy.
So, okay, so from that point on, every son in that family and every grandson
Unless it
will have to go through this procedure if they want kids.
That's sad. Unless
Yeah.
like
Unless they don't want
chances
kids.
somehow mutates back.
Right, unless it mutates back, but the odds of that are
One in two.
pretty small. Okay, so that's how this works. ICSI, Intracytoplasmic Sperm Injection.
It seemed pretty straightforward.
Yeah, it's pretty straightforward. It seems like it would be kind of rough on the egg because they have to puncture the cell membrane and then squirt that little sperm cell right in there. But let me show you what it looks like. Okay.
So we're just going to go over the egg.
Are you happy with that egg?
Very nice egg. Okay, let's fish for a sperm again. Okay, so he looks pretty good.
Yeah.
Okay, so let's bring him to meet the egg.
This is the new act of conception, performed in a basement laboratory at the University of California in San Francisco.
So here's the egg.
An extraordinary new technique called ICSI, or Intracytoplasmic Sperm Injection.
I'll just bring the sperm down to the tip of the needle.
A single sperm is sucked up into a thin, sharp tube and injected directly into a woman's egg.
Okay, nice membrane break there. There we go. Okay, we're done.
So that's what it looks like.
21 years after the first test tube baby, the science of reproduction has made remarkable advances in the ability to create life. Today, sperm can be frozen in vats of liquid nitrogen and chosen over the internet.
So I'm just going to start by taking a good look at the ovaries. Wow, she has a lot of eggs.
Women's eggs can be surgically removed and fertilized in sterile laboratories. Embryos, potential children, can be frozen and stored in metal canisters for years. Each year, more than 20,000 babies are born with the help of these new technologies. It's a booming field, creating lives that would otherwise never have existed, but also raising troubling questions.
It's an amazing area of medicine in that way. From the beginning, no one really knew if any of these techniques were going to prove to be effective or safe. And so there's a grand leap of faith each time, because the goal is so important, we feel like it's worth that leap.
It's not just a matter of
can we do it? It's a question of what are we doing and why? And is this good for children ultimately?
Kevin and Mina Gates wanted a baby for years.
He's really spread out. It's the type of...
You do your cookies.
You love cookies.
We've had such a wonderful 5 years together. We love each other a lot, and we wanted to see a union of our love, and we wanted to experience what so many people experience normally and so naturally. Just to be able to have our own child. But the specter of having an ill child was scary.
Their fears were very real. Kevin suffers from a life-threatening genetic condition called Cartagener's syndrome.
The lungs are abnormal. Mine don't work properly, and that affects the breathing, and a lot.
Also, it's characterized by situs inversus, which means everything in Kevin's body is backwards. His heart is on the right side of his body. His appendix is on his opposite side. Everything is switched.
A few years ago, it would have been impossible for Kevin to father a child because his condition leaves his sperm defective. But now these new medical techniques make it possible. The only problem is the baby could inherit his Cartageners.
They had essentially a lethal disease that could be passed on to a child. And did they want to pass that on?
I knew that if the worst case scenario is that we have a kid with Cartageners, that's fine. So I was probably much more at ease with that issue.
Kevin has had a wonderful life so far. Kevin has had 45 years of relatively good health, and he has led a full life. He has played all the sports he wanted. He has married, he has gone to college, he has a very full life, he's begun businesses, and has a good livelihood. Who is to say that we are not, even if our child did have Cartageners, she would have had a full life.
You see that sperm in there?
Yeah.
The Gates decided to go forward. But because there were no living sperm in Kevin's ejaculate, Dr. Paul Turek had to surgically remove some from his testicle.
All I wanted was one of Kevin's sperm. That's all I wanted.
Using the new ICSI technique, Kevin's sperm was injected into each of the eggs harvested from Mina. On the incubator shelf in the embryology lab, the fertilized eggs grew into 12 viable embryos. Embryologist Joe Conahan prepared 2 of the healthiest to put back into Mina in the hope that she would become pregnant. Then he froze the rest in a canister of liquid nitrogen. Sadly, Mina miscarried.
I wouldn't want anyone to experience the frustration we felt trying to get pregnant and the emotional sense of loss that we felt.
The Gates are not alone. In 3/4 of all in vitro fertilization attempts, the procedure fails to produce a child. Still, infertile couples will go to extraordinary lengths for the chance to become pregnant.
There's mornings here at the height of the series where you walk in and the waiting room at 7 a.m. is filled with, over 100 patients, and we do 100 blood draws and 60 to 80 ultrasounds. It's a busy place.
Angela, Melanie, and Laura.
Paula Greeley is the nurse manager in the busiest fertility clinic in New York, Cornell's Center for Reproductive Medicine. In recent years, fertility clinics like this one have seen an explosion of patients seeking treatment.
You feel like everyone is going through infertility. There are just hundreds and hundreds of people that I've encountered in New York.
So how are you doing?
Good.
Greeley oversees a staff of 20 that each year monitors more than 1,500 women trying to get pregnant.
Infertility is definitely a different type of medicine than any other area that I've been exposed to. My history is that I came from the operating room, which I thought was stressful. I used to scrub on the open heart cases, and I thought, I need a change. This is stressful. I think I'll go and work in that nice infertility office.
Relax your hand.
Early in the morning, women come in for a series of tests that must be run every day for 2 weeks to determine when their eggs are ready to be harvested. It is a grueling regimen of doctor's appointments and powerful hormones.
you feel very different from the medications, and so it's sometimes difficult to handle your everyday tasks.
I mean, drugs like Lupron, for example, depress me, made me, basically you're premenopausal for weeks on end.
It's a very hard thing for a patient to go through because it's something they want more in life than anything, and it's probably something that they have the least control over. You're hoping that it works, but you also don't want to get your hopes up so that you're not too disappointed if it doesn't.
It does envelop your life. It's your every thought. My husband, who's very gentle and sweet, said in a very sweet way at one point, let's try to talk about something else. And for 3.5 weeks, this was all we talked about. And he was right.
Do you have insurance coverage for any of this ones?
High-tech infertility treatments usually must be paid for out of the patient's pocket because they are generally not covered by insurance.
Okay, how long have you been paying today? Visa.
The costs can range from a few $1,000s to over $100,000 for multiple treatments.
I felt so selfish. I felt, we're spending all this time and money and effort, and I really did feel selfish at times. But we did, after that first miscarriage, it was really so upsetting that I was ready to move on to adoption. And Kevin said, honey, why don't we try one more time?
I just need to collect for your cycle today, so we're going to go ahead and take care of the fees, Elizabeth.
Okay.
Okay, thank you.
Did you see the picture of my baby?
Here's little Isabella.
Oh,
She's just turned 1 last weekend.
Yeah. Well, we only make cute babies here.
Yeah. Dr. Woods is the best.
There are now more than 300 fertility clinics in the U.S., like this one in California, run by Dr. Samuel Wood.
Thanks again.
Okay, we're ready. Anesthesia ready?
I think there's going to be a huge revolution in fertility over the next 10 to 20 years. Virtually no couple will be unable to have a baby, except for those few that are at the extremes of reproductive life.
Like 4, that one's grade 2 plus.
Outstanding. You're on today, Linda.
One couple we worked with, the female partner was a backup singer in a rock band, and she was getting later in life. As I recall, she was 39 or 40, and was very concerned that she would lose the chance to have children that were hers biologically. So she chose to use a gestational surrogate in which her eggs and her husband's sperm were placed after fertilization into a surrogate. She could continue her career and yet maintain her ability to have a biological child.
And what do you think of that?
Awkward pause.
I think that couples should have a right to choose their method of reproduction. And that unless it's outside the bounds of ethical and legal behavior, they should have the right to do that.
Yeah, okay, let's do the bicycle. Let's do the bicycle.
After 3 tries, Kevin and Nina finally succeeded in having a baby last December. Her name is Kieran, and she has no sign of Cartaginer syndrome. But all of the news has not been good.
7 months into our pregnancy, we found out that Kevin's lungs had deteriorated, and he had a very short amount of time to live unless he got a double lung transplant. We are now exploring the lung transplant list at Stanford, and we do have some difficult times ahead of us. But having Kieran, it makes it all worth it for us in the morning. Every day is happy for us.
When I'm holding Kieran, I don't think about the obstacles at all. I'm just smiling, looking at my baby.
Look at Daddy. Look at Daddy. But when she's up, she's fussy. Who does that remind you of?
It's my girl.
All right, so that's all about ICSI.
When was this published?
Oh, a few years back. Yeah, I'm not sure exactly when. Okay, any other questions about ICSI? ICSI?
Okay, I don't really have like a question about that, but like when they were talking about the whole surrogate mother thing, I don't know if we'll get onto that more, but like does the surrogate mother have to have like I don't know, like same blood type or other things, just like the biological mom? Like, is there anything
No.
that, like, it just
No.
anybody?
Right, because during the pregnancy, really, mom's bloodstream and the baby's bloodstream don't mix. But at birth, when that placenta pulls away from the lining of the uterus, a little bit of the blood can get into mom's bloodstream. But during the pregnancy, they don't mix. So that's why, you know, mom can have type A and the baby can have type B, or something like that. So when they use a surrogate mother like the guy talked about, that's just basically a womb for rent. Womb for rent. IVF is sort of like womb with a view, right? Terrible. I could never tell jokes. That's just something I cannot do. Okay, moving along. Preimplantation genetic diagnosis. Another little twist on in vitro fertilization. Anybody want to take a guess as to what this is based on the wording? Gabby?
Testing of, testing the egg and the sperm before you actually implant it back into the uterus.
Okay,
For
or
any genetic diseases.
genetic testing on the early embryo before putting it back into the uterus. Okay, yeah, this is how it works. Okay, this is kind of interesting how this one works. Let's say, for example, okay, remember Tay-Sachs disease as an example. Tay-Sachs disease, a recessive disease where if you've got a situation, let's say, where mom's a carrier. Mom is a carrier. Big T, little t. The big T gene is normal, doing what it's supposed to do. Little t causes Tay-Sachs disease. Dad's a carrier. Big T, little t. What's the probability the baby would have Tay-Sachs disease? Little t, little t. Okay, remember that? That's old stuff, right?
Yeah.
All right, let's say you've got a couple, they're both carriers, and they believe, now this is where it gets a little tricky because everybody's different. They believe that human life begins not at conception, but at implantation.
So it's a bad gene.
If it's bad, if the embryo has bad genes and it hasn't been implanted into the uterus yet, it would be okay. Right, like checking the eggs before you buy them. Okay. Preimplantation genetic diagnosis. Implantation happens about a week after fertilization. Okay, so remember you got the egg, enters the tube, it takes about a week to travel through the tube, and then it implants in the lining of the uterus. Technically, you're not pregnant until you've got an embryo implanted in the lining of the uterus. Technically. That's when pregnancy tests show up positive. Okay? Okay. Are there people who believe, now this gets philosophical, not scientific. There's no way you can know scientifically the answer to this question. When is it a person? When does personhood begin? Does it begin at conception? Does it begin at implantation a week after conception? Raise your hand if you think, and I'll bet you do, you have a belief, you have an opinion, you have an idea personally when personhood starts. Okay. I think most people do. You can't know scientifically when it starts. You know only philosophically or religiously when it starts. You know, there are some philosophers and religious thinkers, theologians, who believe that human life starts at fertilization, at conception. There are some who think, no, it doesn't start until that fertilized egg starts successfully doing its mitosis divisions as it's moving through the tube. There are some who would say, no, you're not a person, it doesn't start until it implants in the lining of the uterus. when a pregnancy test would show positive. There are some that would say, no, it doesn't start until like 2 weeks after fertilization when the first nerve cells start to form, start to fire. There are some who would say, no, it doesn't start till like 3 weeks. That's when the heart starts beating. So you're going to get people, and you're going to get some people who say, believe it or not, there are some who say, no, it doesn't start until birth because that's when the baby takes its first breath on its own. Now that's pretty extreme, right? But there's all kinds of people with all kinds of opinions. This technique, pre-implantation genetic diagnosis, would work for somebody who believes the human life doesn't start until implantation. So let's say you got a couple. Mom carries the Tay-Sachs gene, dad carries the Tay-Sachs gene, and this is how it works. In the in vitro clinic, they let the embryo grow till it's in the petri dish until it's an 8-celled embryo, like that. Now what we're looking at here is a view through the microscope. You see this? This is the tip of a pipette, a glass pipette. A really fine tipped glass pipette enlarged, and they're applying suction on that to hold this embryo in place. And then they bring over another pipette, narrower diameter, and look what they're doing. What are they doing here? Frame by frame, what's it look like they're doing? They're pulling off, they're sucking off, they're pulling off one cell from this 8-celled embryo. Okay, now it's a 7-celled embryo. Of course, they haven't put it back up in through the cervix and up into the uterus yet for it to implant. It's still in the petri dish. They pull off one cell. Now it's a 7-celled embryo. But this is so early, each of those cells hasn't differentiated or specialized yet. We say they're undifferentiated. Okay, they haven't specialized yet. And at this stage, you can pluck a cell off, it becomes a 7-celled embryo, and that doesn't harm the embryo. If you let it grow, then it would go through mitosis, become 14 cells, and so on. You with me? Even though it's late in the day and people are exhausted and tired, you with me? Okay. What they're going to do is they're going to take this cell, this one cell, back to the lab, do DNA testing on it. What would they do if DNA testing reveals that this one cell that they plucked off has Tay-Sachs disease, little t, what would they do?
The implantation people probably think
They would let it die in the petri dish and not implant the embryo. Okay, that's called pre-implantation genetic diagnosis. If on the other hand, bless you, if on the other hand they test that one cell and it turns out to be normal, then they'd say, oh, thank goodness, that's a normal embryo. Let's put it back up through the upper part of the vagina, back up into the cervix, and maybe it will attach the normal, natural way, implant. Okay, so that's pre-implantation genetic diagnosis, or PGD, or PGD. You could call it PGD. You ever heard of it? Have you guys ever heard of that? Pre-implantation genetic diagnosis? Does it make sense?
And it doesn't harm the embryo? Like, with it just 7
They've done it enough times it doesn't appear to harm the embryo. They're plucking a cell off, but it's still so early. The cells haven't specialized yet. It's just a 7-cell embryo instead of 8 cells.
Would they screen for other genetic disorders or just the one that the parents are most likely to give?
Just the one that they know runs in the family. That's a good question. It's kind of expensive to do DNA testing. Okay? Is this going to satisfy the couple that believes that human life begins at conception? No. Wouldn't it be nice if you could test before fertilization? You think there's a way to do that?
Yeah.
Some babies.
Well, it's hard to test the sperm.
You test an egg.
You could test an egg.
Sperm's a little tricky.
Yeah. There's another technique. One more technique. Check out letter D, polar body analysis. PBA.
Check one of those.
So-
Rip off the seed. You don't have to see
Rip off a polar body.
Yeah, you can rip, well, you don't, yeah, you rip off the polar body. This is another view. Now, it's kind of cool. They have to use joysticks, these micro pipettes. This is that Preimplantation Genetic Diagnosis where they're plucking off a single cell from the embryo. You're going to take it back.
There's a signal in this ear back from the ears.
Yeah, test it. All right. This is what polar body analysis looks like under the microscope. You got a pipette here. They apply suction, hold the egg in place. Actually, it's a secondary oocyte. Oh, what's this?
Polar body.
Polar body. This is called an egg holder. This smaller pipette over here is called a polar body sucker. Well, not really, but that's what it does. So they suck out the polar body. This hasn't been fertilized yet, right? Yeah, they pull out the polar body, suck out the polar body, take it back to the lab, and do DNA testing on it. And depending on what's in that polar body, then they'll know what genes are in the egg. Right, if the polar body's in this example, like the Tay-Sachs disease, if the polar body's good, the egg is bad. And most people don't have any trouble philosophically or for religious reasons. Most people don't have any trouble with the idea of letting an unfertilized egg die. Right?
This might be a stupid question, but is there any way to fertilize a polar body?
Oh, good question. No, that's a good question. There have been a few rare instances where accidentally a polar body got fertilized by a sperm. But the polar body's missing all that cytoplasm around it. And so when that happens, I've seen medical photographs of miscarried fetuses that were the result of polar body fertilizations. I wish I had the presence of mind. This was years ago I saw those. I haven't found them since. I wish I had the presence of mind back then to take pictures of those, but they're pretty tough to look at. They're like autopsy photos of miscarried fetuses that were the result of polar body fertilizations.
How far do they get?
And they don't get very far. It's basically just a mass of cells. If you look real hard, you can kind of make out a torso, but there's no heart, no head. Very badly deformed. Very badly deformed. And that's, so it has happened. So, all right. I knew we were going to get interrupted.
Excuse the interruption for a last-minute announcement. Attention, FCCLA members. You will not be meeting tonight to finish blankets. Please make plans to come next Monday, October 1st from 3:15 to 4. And once again, FCCLA will not be meeting tonight after school. Let's have a great dismissal here at Jefferson High School.
Let me show you before we leave. Even though that was an announcement over the intercom, we're not done, okay? I want to show you something on the whiteboard about this polar body analysis. Actually, whoever invented this, I think it's pretty clever. Very clever. Being able to do genetic testing even before fertilization. Now, check this out. Tell me if this diagram looks familiar. All right, let's say this is meiosis 1, where you've got a primary oocyte, does meiosis 1 to make a secondary oocyte in a polar body. If the secondary oocyte gets penetrated by a sperm, remember it divides and becomes an ootid and another polar body, right? Okay, so here's the situation. Let's say mom's a carrier. That's not us. Mom's a Tay-Sachs carrier, so is Dad. So here's Mom's primary oocyte. Big T's on this chromosome, 2 of them because it's a duplicated chromosome, right?
Correct.
And let's say the Tay-Sachs gene's on the yellow chromosome. Now watch this. Meiosis. Watch. Okay. They bring in the polar body sucker. There it is. Suck out the polar body, take it to the lab. What's the DNA test reveal?
It's good.
The polar body contains the Tay-Sachs gene. That tells you that the egg is good. So then we go ahead and add the sperm cells to the egg in the dish. Doesn't matter what sperm shows up, right? Because there's a big T there. They get a baby. All right. That's how that works. EDA. Have a nice day. See you Wednesday.